Coming up on this episode of the IoT Inc. Business Show.
LPWA stands for Low Power Wide Area. And I think, what both Sigfox and LoRa are trying to achieve is communication over much longer ranges at very low power.
I think what's important to state is that we all sort of agree that there needs to be a new means of connectivity. We need to solve the main challenges being energy consumption, cost, and complexity.
I'm sold. In fact, I've been sold since early 2014 when I first started digging into the emerging low-power wide area network market. I'm sold not because it's cool tech, I'm sold because it's affordable. The price makes business sense for a wide range of IoT use cases, some of which we're familiar with, and others we haven't even considered yet due to the current cost structures. In this episode of the IoT Business Show, I speak with Hardy Schmidbauer of the LoRa Alliance and Thomas Nicholls of Sigfox about what LPWA is and the different ways it's sold.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com.
With me today on episode 34 is Hardy Schmidbauer and Thomas Nicholls. Hardy is Director of Wireless Products at Semtech and Vice Chairman of the LoRa Alliance Marketing Committee. And Thomas is Executive Vice President of Communications at Sigfox. Although I started covering low-powered wide area networks about a year ago at my meetup in California, there's now a lot of interest everywhere. In the last month, I've been to Europe and Asia where visibility is high, but understanding is low. Hence the show. Gentlemen, welcome.
Thank you.
Thank you.
So why don't we start off? Hardy, tell me a little bit about yourself and your company.
Sure, my name's Hardy Schmidbauer. I'm the Director of the Wireless Products at Semtech. At Semtech, we've been in the wireless transceiver business for more than 10 years. We sell primarily to a lot of the low-power application spaces today, such as security and smart metering. We originally developed the LoRa technology, but then quickly realized that the best way to get technology adoption for LPWA was to standardize it and form a strong ecosystem around the technology, and that's what we've done with the LoRa Alliance. In the LoRa Alliance, we've standardized the protocol for LPWA, which we call LoRa 1, and already have more than 150 members in the Alliance who are developing solutions around LoRa and LoRa 1.
Awesome. Now, what's Semtech's business model then, Hardy?
So Semtech's business model is we are a semiconductor company. At the end of the day, we are just selling chips. And the other members in the alliance are actually selling the solution and the connectivity, not Semtech.
Okay. And so it's more of selling equipment or embedded systems that all the different are all the different members falling into one of those two categories, or is there any variations?
Correct. So they're at the most basic level is the semiconductor manufacturers like Semtech. Then there are people developing modules, complete applications and sensors, such as a trash monitoring sensor. Then there are equipment makers who are doing the gateways and the network management side as well.
Okay. All right. Well, Thomas, how about you telling us about yourself and your company?
Yes, I'm Thomas Nicholls, and Sigfox is a company that was created by people who've been in the space of what's called machine-to-machine communications for about 15 or more years. And it was created to solve the three major obstacles when it comes to connectivity. In the case of the IoT, which we believe are energy consumption, cost, and complexity.
Okay. And what is the business model of Sigfox then?
Yeah, so in order to address the complexity issue and the cost issue, we've decided to go with a subscription-based business model, where basically customers that want to roll out connected devices don't need to worry about also rolling out a network. So in that way, our business model could be said to be much more similar to an AT&T Verizon, in the sense that you don't really know which antenna you communicate with your smartphone and how it works. We provide the same thing for IoT devices, but allowing them to communicate at a much lower cost and with much longer battery life.
Okay, so this is nice then. So we have kind of two sides or two different options for our listeners. So if I get it correct, if I understand it correctly, Hardy, with your option, then within the ecosystem, our members would then pull the different components that they need. They would basically create their own network. I guess whether it's, I don't know, I guess independent of size, they could sort of make it their own. And in Thomas's, they would just hook onto your network, your network, and you build out everything for them. Am I correctly understanding the two different approaches?
Pretty close. In the LoRa Alliance side, we have the members in the Alliance who are providing the solution to the Oranges and the AT&Ts of the world, who are then selling the connectivity. So yeah, at the end of the day, Sigfox is selling the connectivity. At the end of the day, we are a solutions provider who wants to deploy the network and sell the connectivity.
Oh, so Hardy, so to understand this correctly, then the option that the implementers of IoT have, if they do want to use a low-powered wide area LAN type solution, is still a service to service. They're not actually buying the components separately and creating their own network. You're then selling your components to an AT&T or a Verizon or whomever, an Orange, and then the users are either then going to get a service from Sigfox or they're going to get a service from your I guess it's not really OEM, but your customers. Is that right? Is that the nuance?
Correct. I think that the most of the volume of LPWA, and I think there are a few companies that have the easiest access to deploy a nationwide network. One of those is clearly a telecom, but it could also be a utility, or other companies that have access to capital to deploy the network. But I think as well in the Alliance, there's nothing stopping somebody from buying the individual pieces and putting up their own network as a private network. And I think you'll still have, once you have these deployment of nationwide networks, you still have 20% of the business, which will stay on a private network solution for various reasons.
Got it. Okay, so that makes sense then. So you're saying a majority is going to be on these public networks, similar to the networks that we have deployed today, but then around 20% may actually cobble together their own network, right?
Correct.
Yeah. Okay. Thomas, anything to add on that?
Well, no. I think what's important to state is that we all sort of agree that there needs to be a new means of connectivity, right? We need to solve the main challenges, being energy consumption, cost, and complexity. There are different ways of doing that. We go for one global public network approach without being tied into individual vendors. So we work with all the transceiver manufacturers, for instance. So you can use a Semtech transceiver, but also a TI transceiver, Scilabs, or Atmel. So it's another type of approach where we say that the network should just be sort of available, so you don't have to think about where the network actually is and how it's maintained, which is another approach which doesn't address sort of the private network space which LoRa addresses.
Right. Well, why don't we start with the basics? Hardy, explain what's the definition of LPWA?
Sure. LPWA stands for low power wide area, and I think what both Sigfox and LoRa are trying to achieve is communication over much longer ranges at very low power. And I think everybody realized that once you have long range, there's a lot of downsides to a mesh network in terms of complexity and cost. So it makes sense to go back to a star architecture. To make a star viable, though, you have to have high capacity in the gateway or the base station. But if you have long range, you have, say, capacity in a base station, then you can start to deploy a network efficiently with just a minimal amount of infrastructure and scale it to a nationwide level on a much easier basis than, say, trying to deploy a nationwide network on a mesh. I think is not practical and not cost effective.
Right. So let's talk longer range or long range. What type of range are we talking about here?
The range that I think you need to have with these kind of systems is 15 to 30 miles in rural environments, in the cornfields of Iowa. In dense city environments, it's going to change. You have more obstructions, you have more interference, so you're not going to get in downtown New York, but still achieving a couple mile range in these dense city environments, and then 10 to environments.
Sorry, you just sort of cut off there. So 10 to what? So you're saying 10 to 30?
10 to 30, yeah.
In the rural environments, yeah. Now, what do you trade off? Sorry, what do you trade off? What do you trade off for these longer ranges then? Well,
one kind of key, physical thing is if you typically you trade off range for data rate. So typically these, low LPWA networks have a much lower data rate than was utilized in other communication systems out there. So if you look at Sigfox, they're around 100 bits per second. If you look at LoRa, we're around 300 bits per second up to 1 kilobits per second. So it's a much lower data rate. I think it's optimized for sending a few times per hour, not like a cellular connectivity connection where you could send something every minute or a few times per second if you wanted.
Yeah. And what about the power consumption? Because I'm assuming there's probably a little bit of savings there also.
I think, Bruce, if I can just interrupt, because I think that there's one thing that's important to mention when it comes to the whole story of range that people like to sort of refer to. I think, as Hardy correctly pointed out, it sort of depends on where you are, right? But it also depends on how your device was designed and where your device is located physically. Because it doesn't really make sense to talk about range within the space of the IoT. Because if you have a poorly designed device, we all remember the antenna gate from the iPhone, so it's not just small companies who can screw up an antenna design, right? So that sort of design is really, really important. What's also important to understand is that IoT devices are very often very different from mobile phones. Very often they are static. They're sort of installed somewhere. Let's say that it's a home alarm system. You can't just ask a person to take their fire alarm and go outside if they don't have reception, right? So it's not just a matter of looking at how far can you possibly communicate. It's a matter of having a network that is correctly densified in order to cover all those use cases. So it's a very different type of coverage we're talking about.
And also, I kind of promised myself when we were going to dig into this, but just reach, for example, and being able to go, like you said, your example of having the home alarm system, the frequency bands that we're talking about here, I'm assuming then can travel far, but also can travel through walls easily. Hardy, what are we talking in terms of frequency bands as opposed to, let's say, some of the other IoT communication protocols such as Wi-Fi and let's say 802 11.4 or 11.15.
Sure. From a technology standpoint, I think the sub-gigahertz frequencies, give you the best propagation, the best building penetration. So if you look in Europe, it's typically 868 megahertz, and in the U.S. it's typically 900 megahertz. Asia is also either 900 or 400 megahertz. I think that's kind of the sweet spot for LPWA. Once you go in lower frequencies than that, the antenna becomes too big, and you have, I think, antenna problems of integrating into small devices. If you go up to, say, 2.4 gig or higher frequencies, then you start to have range issues. So that's kind of that 400 to 1 gig is kind of the optimal frequency range for LPWA.
Mm-hmm. And Thomas, your point was, again, sure, we've got our range, we've got our frequencies, but something important to consider is the design, obviously. So you want to look, when you're making a purchasing decision, you want to look at the design of the equipment and just see how it works under different configurations, and then obviously the topology of how the equipment is set out there. Was that the point that you were trying to make?
Yeah, exactly. So we sell data subscriptions, and with that we provide a service level agreement, an SLA. And in order to provide that, we need to be able to know a bit about the devices. So we've got a certification process where each device will have a class 0, 1, 2, or 3, basically defining the radio capabilities that the device has. So if you do a poor antenna design, for instance, then you shouldn't expect miracles, but we'll tell you how to improve on that antenna design. So if you want to do, let's say, a smart meter that will be installed on let's say a water pipe underground, then you better have a good antenna design. So it's very important to work with the people with the whole ecosystem of systems integrators and make sure that they all design good devices so that they can connect correctly to the network.
Okay. No, that makes sense. And Hardy, I just wanted to finish off on the power consumption. What are the characteristics? I mean, I would assume it's a little bit less because of the bandwidth, but maybe I'm wrong because of the distance that it's traveling.
So I think that's one of the most important things about LPWA. I think if you look at cellular M2M, they can serve a lot of applications, and it's mainly because of the power and the battery. I think in what both Sigfox and LoRa and even N-Wave and others in the LPWA space is they architected both the technology but also the protocol. So I think you need a much different, say, protocol to optimize for low power. Our chips are very low power. The technology which is used in the chips in both Sigfox and LoRa is kind of optimized for low power. But I think more importantly, the protocols that are being used are optimized for low power, and that's what's going to really, I think, be able to allow the LPWA technologies to access much higher volumes and applications than could be targeted with cellular M2M.
Mm-hmm. And Thomas, when you go to using the lower powered, let's say, protocols, and I think what that means is it's a simplified protocol set. What are you trading off for that? Like for example, LTE would be maybe the opposite of that when you're establishing a direct connection. What would you be trading off using the lower power protocols versus, say, an LTE protocol for setup?
Well, sadly, there isn't any real magic when it comes to radio communications and power consumption. Basically, the less you communicate, the less power you consume, right? So what you want to do with this type of protocol, with an LPWA approach, is that you want to be able to communicate as little as possible. So you want to get rid of all of the overhead, all of the connection establishment overhead, etc., so that you strip it down to the bare minimum. So the less you communicate, the longer the power. So we, for instance, also allow you on Sigfox to, if you want to, you can go monodirectional. So the device does not even need to receive data. It can just, it can go to sleep, wake up on an event, send a message, go back to sleep. So that sort of gives you the ultimate when it comes to power consumption. But in general, for all LPWA solutions, it's all about communicating less in order to gain longer battery life. And directly, obviously, related to that is costs. Because for industrial deployments, you've got all of the OPEX costs related to people driving around, changing batteries or charging batteries. And the less you need to send teams around to do that, the lower the OPEX costs. So energy consumption is really a game changer within this space.
Yeah, but now if we're to say 80% of the LoRa Alliance's, let's say, customers and 100% of Sigfox's customers, if it's a service, then obviously that's your cost. And I suppose then how that's relevant to the end user or subscribers that would lower their costs because your cost is lower. Is that right, or am I missing something here?
Yeah, I think that's correct. I mean, I think that's why we feel that a lot of volume will go to these public or open networks because it lowers the cost of connectivity for, I think, the entire market space, and it also makes, say, access or connectivity much easier than trying to do it yourself. So I think both from the cost standpoint and also the ease of use, that's why I think most of the volume will go into these open or public networks.
Mm-hmm. Thomas, can you talk a little bit more about cost? And I want to just compare it to, let's say, an LTE or even a 3G or even a 2G, whereas you're probably talking somewhere along the lines, and you correct me because I'm sure you guys have these numbers far better than I do, but you're probably talking around somewhere between 75 cents and $1 per connection per month. First of all, is that about right? And then I'm going to ask you the second question, obviously, is going to be what's going to be the cost for these LPWA, or what's the rough cost for these LPWA networks? So first for our listeners, Thomas, what's the range if you were to do this? Because I think a lot of these type applications, Wi-Fi is not going to work, 15.4 is not going to work, 15.11 is not going to work. So you are going to either have to use some sort of a cellular, I guess, or some sort of cellular connection. So I just want to compare the cost. What are we talking about in terms of cellular connection? And then I'm going to ask you about the LPWA.
When it comes to cost, obviously you've got the data subscriptions, right? And we've got customers who do large volume and they go below $1 per device per year. But what's in many cases even more important is the actual silicon that you need in the devices. If you look at the cost of a SIM card module, it's anywhere from, I would say, $15 all the way up to $40. Depends a bit on whether you're doing 2G, 3G, or LTE. But you can drive that transceiver cost all the way down to around $1 if you do large volume. So that's a real game changer, because what LPWA is about is very often about connecting simple devices or physical things. And a lot of those business cases will only fly if you can get a dead cheap modem, if you will. So you need to get all the way down to about $1 for a transceiver in order to really enable all of the business cases around simple connectivity. So it's not just about data subscriptions. It's also very much on the silicon side, the actual bill of material for a systems integrator.
No, that's actually an excellent point. Hardy, anything to add to that?
Sure. I think your original question was about the, what are the connectivity costs? With the operators that we're working with, I think typically if you look at M2M cellular connectivity, it's in the range of a few dollars per month. When you go down to, say, LPWA, that price will definitely be lower, from $1 per month to $1 per year kind of range, I think, depending on how much you transmit. But clearly they're trying to price segment LPWA from cellular M2M, and I think those are both technologies are serving very different applications. I think they're not really competing in our opinion. They're more complementary to allow you to access more volumes and more applications.
Yeah, no, I think you're right. They are complementary in terms of what they do. But before the LPWA tech was starting to be rolled out, unfortunately, that's what you were using, right? No matter what your application, whether it was a parking meter or whether it was something very simple, you still had to compare it. So what you're saying, So what I'm hearing here is the $1 to $3 per month is on a per device basis, right? That you were talking about from on the cellular kind of side.
Yeah, I mean, I think cellular's between $1 and $5 a month. I think depending on where you're at, and LPWA is going to be between $1 per year to a few dollars per year for connectivity.
Yeah, no, that's a huge. And then I don't want to lose sight of actually the other great point that Thomas made is it's not just the connectivity cost, but it's going to be the transceivers cost. Now in the Sigfox situation, Thomas, for the modem that you were talking about, is that something that is purchased by the customer, or is that something that's provided just as part of the service that you provide?
No, we only focus on the connectivity part. So we have an open approach to the rest of the ecosystem. So we work with all of the chipset vendors, all of the systems integrators, etc. So it's basically the companies building the connected devices that will go out and purchase the transceivers and microprocessors and whatever they need to connect their devices.
Okay, so then to be clear, in an IoT deployment, then we're talking about embedded systems that are going to be both in the sensor or actuator and then what we're calling the modem on the other end to collect that information and then send it up along its way to the cloud. Am I missing anything? So we're talking modems. We're talking about what you just talked about in terms of the embedded systems. We have to figure out how to put them in the sensors, and we need what we're calling modems to be able to receive those sensors. Am I missing anything?
Well, we actually do. We actually do have quite a lot of customers so our biggest customer in Europe, a company called Securitas Direct, which is the leading alarm system vendor in Europe. They're deploying Sigfox in multiple millions of alarm systems. And the way that they install it is actually through an over-the-air software upgrade, because they happen to already have compatible hardware within their alarm systems. And since they also have a 3G backhaul in their alarm systems, they can send, just like you'll receive a new update to your iOS or Android software, they push a new firmware upgrade to their alarm systems, and it installs Sigfox because they already have the required hardware within their alarm systems to communicate directly with our network.
But I would assume that would be on the modem side, not on the sensor side, or is it also on the sensor side?
That's one and the same thing. So within the device, you'll have what you call a modem, which, in technically speaking, would be a transceiver and a microprocessor. So there's only one thing needed for the device to communicate to the network.
Yeah, Bruce, I think you were mentioning the modem is in the gateway, but the modem that Thomas is referring to is the end node. And the modem.
Okay, that's where I'm getting confused.
The modem is really the transceiver plus the micro plus whatever protocol you have packaged up on the end node. It's not in the gateway.
Got it. Okay, so to get my terminology correct, the modem that we've been talking about has not been the gateway; it's actually been the sensor.
Yeah.
And then there's a separate gateway that's also required, obviously, to be able to catch this information coming from the modem.
Correct.
Right?
Yeah, exactly.
And and to Thomas's point about cost, I definitely agree that the end node cost is a significant differentiator of LPWA. Not only the chip and the BOM, but also the battery. The battery is one of the most expensive components, and when you can go to a small off-the-shelf battery with a low-cost bill of materials, I think it opens up a lot more applications for volume.
Yeah, well, let's talk about that. Thomas, I'd like you to take us through the applications and use cases, because obviously this isn't a panacea for everything, and this isn't going to be the right type of network technology or connectivity technology for all IoT applications. So take us through, what are the use cases / applications for LPWA? What's the good ones? What are the ones that are good for, and what are the ones that are not good for?
Yeah. So what it's not good for is data-intensive applications. So applications where you need to exchange lots of data, say multimedia-style data, that simply won't work on an LPWA network. So it's really scaled for small, infrequent message exchanges. Now, examples of that, if we take examples that we've got running on our network today, there's a lot of activity within the tracking industry. So that can be everything from logistics. Say an industrial actor wants to know where their pallets and containers are. So they can, at a very, very low price, track even pallets that carry non-expensive goods. Whereas up until today, they would never have been able to create a business case based upon cellular connectivity for the pallets.
Right.
So that's a big area. But also when it comes to stolen vehicle recovery solutions, that's a very big space. We've got customers who do bicycle tracking. So since you can drive cost and the user experience through long battery life to new levels, you can enable tracking in all sorts of use cases. So really democratize that. And then there's a lot of activity within the energy utility sector. And that can be anything from smart metering within electricity, water, and gas, but also stuff like leak detection on water pipes or irrigation systems. So it might be moisture or soil sensors that you've got installed in agriculture, and they will then send information that can then have valves open or close for the irrigation system. That's another big area, but it really covers very widely. We've got security alarm systems. We've got solutions for home care, elderly care. So now you can more easily deploy solutions in elderly people's homes so that they can have distress buttons and fall detectors, for instance, which is something that was difficult to do before because you needed to provide a solution that would require an elderly person or their relatives to change batteries very often, which is a bit complicated for elderly people. But also the customers we have, they've got elderly people, so regions that have elderly people living in regions where you don't even have GSM coverage. So in order to get out to those areas, it's much easier for us since we cover more widely with our network infrastructure. So it really covers very widely. But just to finish off with the applications, I think the most exciting thing about LPWA is all of the applications we don't know about today. We learn every day about new use cases, and that's what's going to be huge. There's going to be so many new applications that we've got no idea about today. I mean, we just had a new customer that puts sensors on trees in forests, and all they do, those sensors, is that they measure for big changes in temperature. So if there's a large increase in temperature, it'll detect the wind speed and the wind direction and send that data to the fireman, so that the firemen can move out immediately and they know exactly where the fire is going and how quickly it'll spread.
Now, what were you saying? I can't remember. I think it was you, Hardy, but maybe it was you, Thomas. What were you saying the battery life is typically here?
I mean, battery life is kind of one of those hard things, like range. It depends on a lot of things, right?
Sure,
so it depends on how often you transmit, how much you transmit, what power you're using in the chip. But so it's
but for these type of applications,
clearly for all of the applications that we're targeting in LPWA, you want to achieve multi-year battery lifetime off a cheap, low cost off the shelf battery. So I mean, in a lot of applications, the application can be deployed longer than the lifetime of the battery. If you look at communicating once an hour with LPWA. You can last typically longer than, the leakage in the lifetime of AA or AAA batteries.
There's actually a very good point Hardy has there. We've got a customer who's certified his devices for 20 years of operations, and they do leak detection. So it's a very simple use case, obviously, and they don't communicate a lot. They just send a message saying that the device is working, I think, once a day, and then they send an alarm if it detects a leakage. But for those use cases, just like Hardy mentioned, one of their new problems is to make sure that their battery supplier can actually certify their batteries for that long.
Right. Okay, now I get it. So you guys are saying that you may need the battery for 20 years, but the battery may not be there for 20 years. It's just, you only require that. I mean, you only require enough energy that theoretically the battery would last that long. However, batteries don't necessarily. That's interesting. So what you're saying here is the limiting factor in some cases is battery technology, not necessarily the, I guess the protocol technology or whatever, however we want to wrap this up. Hardy, we've talked about, I'm talking about the use cases here for LPWA. We've got tracking. We've even talked parking meters, security alarms, smart metering, leak detection, even some home home care applications. What other ones can you color it out a little bit more for us?
Sure. I mean, I agree with a lot of the ones that Thomas highlighted there. I think if you look at the telecom operators we're deploying with, there's kind of three main categories that are kind of justifying the network deployment to get the ROI, and it's supply chain. So anything where you're sending out somebody to fill something up or pick something up, there's a labor cost, there's a transportation cost. Those are a lot of the applications that we see in LPWA. Agriculture is another one. If you look at water consumption in the U.S., 80% of it goes to agriculture, not residential. Right. So there's significant savings in water and say the value of the crops, and also the amount of fertilizer and pesticides that you use that can be saved with LPWA and a low cost sensor. And the other one is intelligent building. Security systems, but also, usage of the building. Do I need to go and clean the building because, nobody used it today? There's a lot of, say, savings in value in those type of intelligent building applications as well. But, I think one of the biggest segments is going to be in this, asset tracking space, being able to do, low-cost localization of devices. I think opens up a huge market segment, and I think that's one of the the key differentiators of LoRa is being able to do that tracking at a very low cost, and I think that'll open up potentially one of the biggest, say, application segments for LPWA.
Yeah, so for our listeners, if your application, so we've many that are developing their own applications or use cases, and so what we're saying is technically if you're somewhere between 100 and 300 bits per second, this is a candidate, right? And it's obviously not a candidate for a real-time IoT system. It's not a candidate for any, I guess, more dense unstructured data, but it is a candidate. And I agree with you guys that this is a whole class of applications specifically around the infrastructure side. But yeah, it goes into the commercial side and the industrial side, and I guess the consumer side too. So this actually pretty much covers the whole range for that particular class of applications. And what it does is it enables, just because of the cost structure, it enables these type of applications to happen, whereas before it just wasn't possible when you had these longer range type technologies. And it kind of brings me, to my next question is, what are the mobile operators doing then? I mean, specifically, I've heard a little bit about a LTE-M. Am I correct on that one? I mean, because if they're paying, I think a part of what the cost structure here is using the unlicensed frequency band. Now, obviously, when it's unlicensed, you may have interference issues. There may be a few downsides, but the big upside, obviously, is going to be cost, because you're not having to lease it or you're not having to buy it. So, is that the biggest? How are the operators that are actually having to lease these frequency bands, how are they going to compete, or is that even, or is it just not competable?
I think it's completely different applications, and even if you talk to the AT&Ts and Verizon, so everybody will admit that they can only connect 10 to 15% of the volumes that are predicted for IoT with cellular. So Verizon realizes that, the AT&Ts, the Oranges, every big telecom operator, realizes that already. So I think it's not competing, and that's why every operator, I think, on the planet now is looking at LPWA and doing technology evaluations of what's the best option for me to deploy for LPWA.
Thomas, anything you want to add?
No, completely agree. I mean, we've got three of the world's largest operators as investors in our company. And if you go into a Telefonica store anywhere in Spain, you can buy a B2C alarm system that uses our network. So I mean, it's not a question anymore. I mean, all MNOs in the world will agree that there's a need for a new and complementary connectivity solution. And we see more and more use cases where the two are combined. For instance, to avoid GSM jammers, which you can buy off of eBay at $10 today. If you add Sigfox to the alarm system, your alarm will still go through. But also, I think that we'll see a lot of use cases where LPWA will be used to actually prolong battery life in GSM-based systems, where you don't necessarily need to have your GSM module active permanently, where you can actually use, say, a Sigfox connection or an LPWA connection to wake up the higher level communications protocols. So I think that there'll be a lot of complementary usages out there in the future.
Yeah, no, I like that. So let's talk about the technologies now. We originally were going to have N-Wave on the show as well, and they didn't make it. Proprietary versus open. What are your guys' stance here? Now, from what I understand, both Sigfox and the LoRa Alliance are talking about proprietary protocols. So is there a licensing fee, or why are they protocol versus an open? And does that, and what's your perspective on that? Both of you guys. Maybe start, Thomas, if you can start.
Yeah, I mean, I think it definitely needs to be an open approach, because at the end of the day, no actor within the IoT will provide the entire stack. You can't be you can't deliver both the devices or the hardware, the software, the connectivity, etc. So you need to play your role within the ecosystem. And that's sort of our approach to allow people to use any sort of transceiver, any sort of systems integrator, any sort of software platform. And we allow our users, without any hardware changes, to switch from Sigfox to any other network if they want to. So you can go and you can use a Semtech or a TI transceiver, and you can host within your device multiple network protocols. So you're free to switch from any network to Sigfox or vice versa. So that whole openness is going to be key. And we participate in all of the standardization groups to try in the future to build up solid standards around the LPWA space.
Hardy?
Sure. I mean, I agree with Thomas, and Thomas's Sigfox is very open on the end node side, but at the LoRa Alliance side, we've taken it one step further, and we've also opened up the spec for the gateway and the network server side, which is closed in a Sigfox system. So I agree. The only way to really scale, I think, technology adoption, and I started with this, is with standardization on the protocol and the end node side. But also a strong ecosystem to deploy and scale it. I think it's very difficult to get mass adoption with one company. You need an entire ecosystem that are pushing the technology.
But just let me,
if I can, because I have to comment on that in regards to taking it a step further, because it's basically two different approaches, right? On one, I mean, Semtech sells chips, right? So if you want to do LoRa today, you have to buy a Semtech chip. So for us, that would not be a really open approach. We believe that it needs to be possible to choose between the different transceiver manufacturers. So that is key. On the network side, our approach is not about selling networks. It's about saying that there needs to be global networks. So it shouldn't be about having a fragmented network space, because when you've got fragmentation, you've got complexity, meaning that companies will need to know where their devices will be deployed so that they can integrate with the backends of all of the different operators of those different networks. And they'll be difficult, in our opinion, to provide a real service level guarantee. So it's basically different approaches, right? But I think it's unfair to say that Sigfox is a less open approach than something that comes from a transceiver provider.
So, I mean, I think that's one of the main complaints of LoRa is that originally it only came from Semtech, but Microchip's already developing not only modules but also silicon with the LoRa technology, and there should be another announcement soon of another major semiconductor company adopting LoRa.
But microchip, that is still Semtech transceivers, right?
No, they're doing their own integrated devices now as well.
Okay, so today I can go out and buy a transceiver from Microchip?
Not today, but in the near future, it's in development. Today you can go buy a module from Microchip, but very near future you can go buy an integrated, micro plus transceiver from Microchip.
And let me ask you though, from a listener's point of view, if we're developing, I'll say an application, but maybe that is not as pertinent as say a modem or a gateway. Are there any costs that they have to incur to be able to connect up? So to actually build I guess so in the Sigfox situation, yeah. So are there any costs that they have to pay to either the LoRa Alliance or the Sigfox to be able to build equipment that'll work with the network protocols, I guess is the right way to say it?
I think no. I think Thomas and I'll agree there that you have to keep the costs low, and say any royalty for software or anything like that creates margin stacking, which I think is not what the space needs to scale. So I think everybody's trying to make it widely available, open, easy to access, easy to develop on, with no, say, royalty or cost associated with the development.
Okay, so developers do not have to worry about an incremental cost. What they have to worry about is going to be that subscription model that they're going to pay to either Sigfox or to I don't know if OEMs, right? So I guess an MNO on the LoRa Alliance. Yeah, is that the only cost that we're having to think about?
Correct. Yeah.
Yeah, and okay, so in terms of cost, so that's getting back into the business models. You guys aren't making money off of you're providing it royalty free, and I think Thomas, you mentioned a couple times that actually existing chipsets might be able to or I don't know what the percentage is, but existing chipsets will be able to run your protocol. But also, if they were to utilize a specific chipset, there's no cost there. So both your business models on the Sigfox side is we're putting it all out there. Here it's free if you want to connect it to our networks. However, we're going to charge you this amount per whatever. And on the LoRa side, even though 20%, they may build up their own network. So that means there would be costs associated with the infrastructure. But for the 80%, again, it's the same thing. It's just you're just only going to have to pay us a cost per month, cost per year. Is that the metric?
Yes, correct.
Yeah, Thomas, are you nodding your head as well?
Yeah, I'm nodding my head again. What we're seeing is that a huge part of the devices hooking up to our network are devices that already have transceivers from any sort of vendor out there, right? So a lot of the market we already have is based upon hardware that is already out there in the field, which is why it's so key for us to have an open approach that works with transceivers from any type of vendor. So as it is today, I would say maybe half of the connections we have are from devices that already have actually the required hardware in them. Okay.
And what was I going to say? You were just reminding me then on the performance, I guess, since this isn't super high performing, you don't really need a specific hardware. You're saying you can just utilize. You're basically running in software on different hardware. It could be a more generalized approach. Is kind of why it works, right? Thomas?
Sorry, I didn't understand the question, Bruce.
Yeah, I don't think I said it very well. I guess what I mean is since the networks, if we're only transmitting 100 to 300 bits per second, performance isn't of paramount, and so therefore you don't necessarily need specific hardware designed to support the protocols, and that's why you can use a general piece of hardware or a hardware that was built for something else to run your software on top of it, as opposed to requiring a specific embedded system.
Yeah, exactly. And I think that one of the conclusions that people should retain from this podcast is that the magic of LPWA is that it's so dead simple. And it's only by being so dead simple that we can provide the advantages that we can provide. So that means that on the device side, we're doing everything we can, all of the actors within the LPWA space, to make it as simple as possible. And all the way through the chain of connectivity, of communications, it's about making it as simple as possible in order to be able to support very low ARPUs, so making very little money on each connection, and really enabling any sort of simple thing to connect to the networks.
Okay. So, but obviously everything isn't 100% rosy here. Now, with the exception of, or notwithstanding the bandwidth issues, what are other issues? And Hardy, I'm going to start with you. What are some of the biggest issues that business leaders need to consider when looking at an LPWA system? And don't give me all the good stuff. I want to hear, what are some of the serious things that they need to consider when making the decision?
I think most companies realize that LPWA is necessary or needed at this point. I think then typically people move to a technology evaluation phase, and after that it really comes down to an ROI. I think a lot of these applications that we've talked about today, some of them there's an existing market, but a lot of them they aren't out there, and it's saying getting those customers to say, my network deployment's going to cost X, and here are the 15 lead customers, and that's going to give me my return on investment. I think a lot of it is around not necessarily the technology or LPWA. It's can I get the return on investment of my network deployment?
So you're saying that although LPWA provides all this greatness and for this type of segment, you're saying something, a big issue to consider obviously is, can you sell it? Is there going to be a market for this technology? Is that summarizing what you said?
Yeah. I mean, and I think those decisions are coming out favorable for LPWA. I mean, you're seeing lots of announcements by Orange and Swisscom and KPN and Proximus that people are making those favorable ROI calculations. But a lot of the people we are engaged with are currently in that phase of, especially for the U.S. and maybe some of the bigger countries, right, where it's a bigger expense to deploy the network. They're looking, it's going to cost me, whatever it is, $100 million or $200 million to deploy the network. What's going to be my return on investment of that network deployment?
Okay, so yeah, that's right. You're talking about it in that case on a network wide deployment, and I guess I was talking about it, and I think you originally were getting at that, but I was talking about it on a application based. Whether I use, should I use LPWA? What are the got-yous? And you're saying, I think the got-yous are just make sure you've got a market for your product, even though the tech may be there. Yeah,
I mean, I think there's a lot of issues with some of the the previous. If you look at metering, for example, there was a push for standardization a few years ago, and that's kind of unraveling at the moment, I feel. And they're starting to open up and look at these new technologies, because I think some of the technology adoption that has been done previously is not working that well, and maybe LPWA is a new space. So I don't view concern so much from the people we're engaged with. Are they concerned with LPWA? I think everybody's kind of realizing quickly that that's maybe a better option for a lot of the applications.
All right, Thomas, I'm trying to squeeze some I don't know, negative juice out of Hardy here, but I'm having a hard time. Maybe I'll have a little easier time with you. Give me some of the got-yous. What are some of the things that people really have to consider? It's not all a panacea here. It's not all perfect with the LPWA.
Well, it is. Actually.
Come on.
No, but what I would say, which is not sort of a negative point, but what I see and what I'm happy to see is that we're seeing a lot of new entrances within the space of connected hardware. So, for instance, we're seeing a lot of startups that start building solutions for the Sigfox network, and a lot of these guys are entering the space because hardware has sort of been democratized. So it's more cost efficient, lower cost. It's more easy to get started prototyping, they already know how to do the software part, right? So they get sort of eager about this space. But if they don't have the background within hardware, they still have the challenge to understand how do you go from a prototype to actually scale up to mass production. And I would say those are some of the new exciting challenges that the space is seeing now, because it's new people that just couldn't really create connected solutions before. Now they can, but they are facing sort of new challenges to really get to understand this new space. But those are just good issues to have, and all of us within the ecosystem of the IoT need to work together in order to help all of these new guys joining the space to get up and running as quick as possible.
I got one for you, Bruce, I think.
All right.
I think if you look at the open network model, public network model, security is a common concern brought up. Is that, how do I know that my data is protected? And that's one of the the key things that we tried to make sure was integrated into LoRaWAN was good, strong security for both the network layer, but also for the application. But I would say that's one of the most frequent brought up topics or concerns about LPWA is the security aspect.
But if I'm understanding it correctly, I'm assuming, this is going to be the network protocol, but I'm assuming then you can embed this within whatever security protocols, for example, if you want to encrypt it, or you can still use all the same best practices that you would use for any other network protocol, or is there something unique here? I'm assuming that LPWA doesn't have its own specific security system, right?
Well, we did it in LoRaWAN. Yeah, we embedded two different levels of AES encryption, which I think is critical. And I think you need two-way communication to do that key exchange to make it secure. So we definitely put a big focus in defining the protocol to make sure that even there's a network layer of security, then there's also another layer of application security, because you may be city of San Jose, and you don't want whoever is operating the network to be able to access or look at your data. You still want your data to remain encrypted till it hits your, say, application server. But you also want to protect the network operation, so you also have to have a layer of security there.
Interesting. So you're saying, so how far up the stack then do both these protocols go? I was thinking that it was more just on the MAC-PHY layer, but you're implying that it's going up all the way up into the application layer?
Correct, because we want to make sure that say payload data of the end sensor remains encrypted until it hits the application server of the customer.
Thomas, you have a different view on that, or is that the same for Sigfox?
No, definitely these networks are secured and need to be secured. That is definitely critical. At the end of the day, what we transport is the customer's data. So obviously, the customers will have their own sort of vocabulary and their own mechanisms to secure data as well. But the security on the networks need to be up to par, of course, as well. That's critical.
Yeah. No, I agree. And then I guess so that is something to look at. Obviously, the two initial ones you guys brought out were relatively softballs, but that is make sure you've got a business and then make sure you understand how to go to market. But security, you're saying, is also something that has to be considered. And I agree. And I think that's a best practice no matter what networking protocol that you're going to use. All right, guys. Well, I think that was great. I want to ask both you, Hardy, we'll start with you. Where can people find out more about you and your company and your alliance?
Sure. If you go to semtech.com, you can find out information on the LoRa technology and the transceivers. I think more important is to go to LoRaAlliance.org. And see who are the members there. We have our upcoming next members meeting in Rotterdam, Netherlands, in 2 weeks. It should be a huge turnout of 600 to 700 people, and more than 150 companies will be there. So I think a very exciting time in the formation and growth of the LoRa Alliance.
Okay, and that'll be November 2015. Thomas, what about on your side? Where can people find out more about you, your company, and so forth?
Yeah, so general information is on sigfox.com. Also, if people want to learn more about us, we've got a hackathon that we just announced with organized between us and the city of San Francisco, and a few other partners will be revealing shortly. That is coming up at the end of November. So there'll be problem statements from the city of San Francisco, where we have just announced that we've rolled out the network. And then we've got different events all over the world where people can come and hear more about Sigfox.
And they can go to your website, which I'll put all this information from both you guys in the show analysis notes. But they can find out where these events are on your website. Is that right, Thomas? Sigfox website.
Yeah, exactly.
It's the same for us as well. We have boot camps and workshops on a monthly basis and all the geographies, and starting to do a lot of hackathons with the telecom operators who are deploying LoRa. So all that can be found on semtech.com as well.
Nice. All right, guys. Well, thanks a lot. I truly believe in the LPWA space. I think like we've talked about in today's podcast, that there's a lot of use cases that make a lot of sense now that the cost structure also makes sense. So with that, I'm going to thank you, and we'll talk to you soon.
All right. Thanks a lot.
Thanks a lot.
Okay. Well, that was a very informative talk with Hardy Schmidbauer and Thomas Nicholls. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support this show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is Technology Lessons for the IoT Professional by me. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be a low-powered one.
You have been listening to the IoT Inc. Business Show.